It's actually if you close the bow tie and
Bow tie, brilliant, cool.
things I
Um,
keep wearing for work.
nice. Oh, you didn't turn up in the bow tie today. Never mind. So I'm going to switch things up. I introduce the session first, and then introduce myself and you. So people who've seen Calico Live a few times will know this by now, but this is Calico Live. It's an informal live video stream series, and the idea was that we wanted to come up with a more relaxed way of learning about Calico and about Tigera. So we do have a very loose script for this, but not like a normal webinar. You know, we just have some bullet points that we want to hit. So we did up to episode 5. We did 5 episodes, which were about the eBPF data plane. So those are quite interesting, I think. If you are interested in that subject, you should go back. Episode 6 was a special live birthday special with Ratan Tipinelli, who is the CEO of Tigera, which is really insightful about the past and future of the project. And then we had Casey Davenport, who's principal software engineer, for 2 episodes. So those were really great as well. So this week, episode 9, will be focusing on the VPP data plane and demoing Calico and VPP with MEMETH, which is exciting. My own knowledge is not amazingly good about MEMETH, so I'm going to learn a few things myself. My name is Chris Tompkins. I'm a developer advocate at Tigera. I champion user needs and support our users and our contributor community. I've been doing networking since about 2000, but developer advocacy less time, so it's quite exciting for me. So our speaker today is Nathan Skrzypczak. So Nathan, did you want to introduce yourself?
Sure. So hi, I'm Nathan Skrzypczak. I'm a developer at Cisco, and I'm working in the VP project. So it's a user space data plane. I joined a couple years ago, and I've been doing really different things before, but since then I'm really interested in the making fast data plane for containers. So I'll try to explain a bit more in depth what's going to be forward.
Yeah, cool. And as Nathan said, these sessions tend to be quite high level at first, and then we go into quite a lot of depth. But the cool thing is it's live, so we are happy to take any question at all, and there's no question that's too easy or too hard or anything like that. If the question's too hard, we can take it offline and get you the answer. And if it's easy, then that's fine. We just cover off the later material in a later session, and we drag Nathan back here over and over again. So yeah, please feel free to ask us questions. You're helping us out if you do. So with that said, before we dive into VPP too much, I just wanted to ask a bit more about you, Nathan, and how did you get into coding in the first place?
So actually, that was a long time ago. I'm not that old, but I fell into code when I was really young. My dad was quite interested into electronics and stuff, and so I started playing with his old equipment, a ZX, which was more of a calculator than a computer, but I started programming basics on it. And actually, so my parents were quite strict. When we were playing the computer, we only had 30 minutes per week, and we had to play with the Pomodoro. And I figured out at some point, if I tell my mother, "Oh, I'm not going to play, I'm going to code," I was able to negotiate more time and even get a computer afterwards. So
yeah.
So that's
Yeah,
that was pushed me to it.
it's so funny how many times how often the story is that people were trying to get their games working or trying to get extra permission to play more on the computer more time. Funnily enough, my daughters, I quite often get them to do like some simple programming stuff, and so history repeats itself. Cool. How about networking? When did you actually start coding things to do with specifically to do with networks?
So networking specifically, that was in university that I really fell into the topic, but it's really, so the interest for the field in general stems from quite a bit before. So I've always been fond of physics and really so problems that you find in nature and really the mathematical equations describing those. And I think that networking is really the spot where you can combine really programming and solving actually complex problems that arise from the complexity of the field. It's one of the few places that I found that the way you write your code and the machine beneath really is of huge importance to the effectiveness of the code. So if you don't choose the right data structure, your code won't work because it won't be fast enough.
Yeah.
So
yeah, for sure. That's something that happens because I'm not at my first part of my career is not programming. So yeah, quite often I write code that's quite naive and it doesn't map well onto the hardware. This relates to the stuff we'll talk about later with the data plane stuff. Like if it maps well onto the hardware below, then the performance is so much better. Yeah, it is quite interesting. And even though I've been doing networking 20 years, the more I learn, the less I feel like I know. There's so much depth. Especially, I was learning about queuing and internet queuing and window control and that kind of stuff. Man, it's complicated. It's complicated.
And it's impressive how long it dates back. So it's been CCPs has been like 20 years something.
Yeah.
And we're still negotiating IPv4s recently, saying 127 that one we can grab. So
it's a shame they chose an entire /8 for localhost. I often think this. What about getting specifically into VPP or did you start programming any other kind of SDN stuff before VPP or?
No, that was the first project I worked, the first SDN project I worked on in. So before that, I was in completely different topics. So I ventured onto JavaScript, CSS, and machine learning. But yeah, at some point I felt so that adventure didn't go that well. And at some point I had a couple of friends who were doing their PhD thesis at Cisco, and I was quite unpleased with my previous position. I said, I might want to go back to doing a bit more deep coding and say, did you check this thing called VPP? I say, what is VPP? I say, that's this really great project that some guys here have. You might be interested. So they might be have an interesting position for you. And that's how I got into the project. First, I did work on a few features within VPP. And then I moved to larger SDN deployments, and that's what led me to discovering Kubernetes and Calico and the inner workings of it.
Mm-hmm. Yeah. I got interested in SDN because I was kind of configuring devices one at a time and just starting to think this can't be the smartest way to do this. It can't be the right way to solve this problem. So, cool. So how did VPP for Calico actually come about? I actually honestly don't know this. I'm not asking the question for the sake of the camera. I'm not totally sure. When did the conversation about putting VPP into Calico first start?
So it's actually it's quite a while ago. So specifically, putting VPP into Kubernetes, there have been a lot of discussion about that before a few projects that started implementing that. And the main idea was we have this great beast that is VPP, and that we have put a lot of features in. It can brew coffee, it can do anything you want, but it's really hard to get it into the hands of an endpoint application developer, of someone that. So you have people wanting to configure it from the scratch, but it can be a bit tedious. You have to configure all the interfaces, know the drivers, this and that. And so we told ourselves there is Kubernetes, which is really gaining traction. It has this great model, and people are adopting it, but it's not really adapted to. It only solves the endpoint applications. There's not much things done for packet processing, and VPP has some features that are missing there. So maybe you could do something there. And it will help us also bring VPP in, so package it in a way that's easier to consume for application developers. Put it in a way where it's easier to leverage features. So that's sort of the discussion that took place. And so we started investigating what had been done previously, the different projects, and we searched for a CNI, and we came across that great CNI, which is Calico, and we told ourselves, oh, that's really nice, because so first it had the same philosophy, targeting high scalability. So it built around BGP, the fact that it's able to scale to a great number of nodes, a great number of routes shared. So even the control plane is built around this idea of supporting performance. And also there was already a really neat decoupling between the layers, the control plane and the data plane, which allowed us to say we might be able to insert there, so we won't have to push too much changes into the architecture, the way Calico is structured, in order to insert ourselves there.
Yeah, there's a couple of points I think are interesting there. The first one is you made the point that it was initially before integrating with it as a CNI. It was, your word was, I think you said tedious to do that work. But I think that partly it may be a little bit tedious, but also because you have that depth of knowledge. It not just tedious, but there's a huge barrier to entry there, or there was before implementing as a CNI. There's so much knowledge there required just to get something. So yeah, it's a perfect fit. And then the point about the fact that it was easy to plug into the stack, that is I think a really important point. And I've said it a couple of times on these sessions, but I've been so pleasantly surprised since joining the project to realize how well defined that model is, and how therefore it makes it so easy for this kind of integration. We've got a few viewers on at the moment, so I just want to say before we move on to anything else, just remind people that we are really open to questions. So if you want to know anything about the background, the background of either Nathan's background or VPP's background, and if we don't know the answer, like I said, we can always come back to it. So feel free to shout out any questions. So you've kind of already alluded to this. I was going to ask you about how easy it was to get plugged in to the rest of Calico. So I know that there's the four tiers. You have the kind of, there's a data plane abstraction. I think it's called data plane driver, which is like I think it's like a shim kind of abstraction layer. Yeah. And then the data plane itself, and then the calculation graph. So where are you actually plugging in? Is there a data plane driver in the VPP model?
So we in Calico we plug in as a data plane. So in Calico there is this thing called the external data plane driver, and we plug in as it basically it calls us. So I don't remember if it's a gRPC API or just regular call to a process, but we get called in a way, and we receive. So you have an option, you have a switch that you flip in Calico, and that selects the external data plane driver, and we just put ourselves below that drivers, and we just received calls that tells us there was this new pod created. Here are the IPs. Here are the routes to it, and all the characteristic. It lives in this NetNS, and please do the work so that we can talk to it.
Is there? So I apologize for this question because it wasn't a question I shared with you in advance. So sorry for that, but it's just something that pops into my head now. Is there a lot of complexity in terms of the order in which things need to come up when you enable the new data plane? Because presumably you need reachability between the various components in order for them to be able to establish their state initially. Is there a lot of sophistication in how that works, or?
So not that much. So there is a bit of sophistication from VPP standpoint, because but so that's a bit complex. But so once VPP has started, things start to flow fine, because once you are able to speak to the API servers, most things happen fine, and then you just set up containers. The tricky part though is that as you already have a machine with an interface configured, and usually, so for example, if you spawn an instance in EKS, you only have one interface. and you're SSHing through the instance through that interface.
Yeah.
And in order to deploy VPP, what we have to do is we have to grab that interface, put it within VPP. But once you do that, Linux doesn't have interfaces anymore if you have only one. Just blind. So your SSH connection is essentially dead. And there we have to restore the connectivity within Linux, create an additional interface. And that process can be a bit tricky. So there is a fraction of time where the machine, the API server is blind, but that's usually sub-second. So
yeah. Does the SSH session persist? I can't actually remember from when I did this myself. It does. That's brilliant. Yeah, cool.
Yeah, it does.
Because I think anyone who's ever managed a network for a living knows that the worst feeling is when you press enter on your SSH session and nothing comes back.
We went through that pain, but normally it should be okay.
Oh god, as long as it's not a production environment. Unfortunately, I have had that experience in production environments, and it's not an experience I want to repeat. Yep. I feel nervous just thinking about it. Yeah, cool. All right, so we don't have any new questions. So let's move on to the latest developments, and that can be either if you want to start talking about MEMETH, great. But if there's other things you want to tell us about first, then that's cool too.
Yeah, I think so. So I was obviously going to say MEMETH, and but I think I can keep it for a bit later, if also with the demo that might raise questions.
Yeah.
So apart from MEMETH, we have been working on quite a few features recently. So there is VCL, which is a bit complementary feature to MEMETH. MEMETH allows you to do packet processing at high speed. But VPP also comes with a host stack, so meaning TLS, UDP, Quick, and TLS implementations that you can leverage from within a pod. And so we added that feature in the latest release that we did, where in a pod that requested, you get an abstract socket and you can consume that and benefit from the optimized network stack within the VPP. And we are currently exploring the way to integrate Envoy with that. So Envoy already works with the VCL, so there is a POC doing this. And we are trying to bring that POC within a Calico VPP cluster, and maybe deploy a service mesh around that that benefits from the speed up the VCL gives you. Very
nice, cool. I suppose this is a good time to say that if anything that Nathan is saying or I'm saying sounds interesting to you about VPP, if you join the Calico users Slack, we have a VPP channel in there. So if you just Google Calico users Slack, then Nathan is often in that channel, and if he's not because he's busy working on stuff, I can certainly put you in touch with the right people. So yeah, if any of this sounds interesting and you want to get involved, either to try it out or to get involved with helping with any of it, then please do. We'd love that.
Yeah. Also, this is a lot of ongoing development. So there are also things that are settling in. So if you want to be involved in, so all this is open source, obviously. So if you want to contribute or share use cases, that would definitely be really interested in it.
Yeah, I'm jealous of younger people starting in the industry, because there wasn't this ability to collaborate on Slack when I started in IT. There was no, well, actually. I'm sure if you knew the right people, then probably there was an IRC channel somewhere, but it wasn't as easy as it is now. So get involved, definitely. So all right, before we start to talk about MEMETH, what do you see as kind of some key characteristics for VPP with Calico?
So I would say the main characteristic we tried to keep in mind when doing it was to keep it as transparent and split from the existing Calico, so separated from the Calico integration as possible, so that it's only a switch to flip. You can install it, remove it, and it lives really in a different component. That's why it's also it's in its own pod, living in its own space, and it should stay mostly transparent from the user standpoint. Another characteristic is that we really wanted to decouple the data plane from the underlying machine, so really enable a user to basically inject its own data plane without having to care too much from the underlying infrastructure. So you could imagine compiling VPP for Windows. So that we don't do this right now, but that could be done, and you would have the exact same network functions on Windows as on Linux. So we really wanted to decouple the data plane from the environment you're running in, and all this to target the what I think is the main characteristic of Calico, the Calico VPP integration, is that we wanted to use it as a platform to provide extensibility in terms of feature. So we use that to speed up a couple of different use cases. For example, if you want to do ingress for endpoint applications, we added a magdev implementation. If you want to do so I spoke earlier about VCL and Envoy, so that's also something we brought in, the ability to speed up some transport protocol. We also brought in an IPsec. So really, it's really a bit of a plug and play platform to integrate things. To add things to, let's say, network flavors to an existing Kubernetes cluster.
I'm really struck when you describe it. I'm really struck by how good a fit it is in terms of the actual the paradigms of how you've designed it and how you intend it to fit. Because the idea of it's one of the fundamental ideas of Kubernetes is everything should be separated and modularized and namespaced, and treating the CNI in a really modularized. That's a perfect fit for Kubernetes, right? And then earlier on in our conversation, you talked about how the scalability stuff. And when I first implemented Calico as a user, I was going to say many years ago, actually, probably 2.5 years ago, something like that, 3 years ago. I remember just feeling confident because I knew the protocols and I knew the scalability of the protocols. So I knew that, okay, this is just BGP, and I know how far BGP can scale because I've built networks with it. And so I feel totally confident that it will scale and everything else, whereas older SDN or, OpenFlow or whatever, you think, unless you have a PhD level understanding, it's hard to know for sure that, that it's going to scale.
Yeah, no, for sure.
And there was another point you made as well about, what was it? Yeah, I forget actually. I think you made one more point as well that there was a really good fit for the design of Calico. It'll come back to me in a minute probably, or more likely it won't until later on this evening. So cool. All right. Well, let's so before we move on, let's just ask if anyone has any more questions, and if they don't, then let's get into Memif. And this is going to be quite interesting for me. So. Like I said, there's I told you before we started, there's kind of a 15-second delay on the video, so we'll give people a moment so that if anyone does type a question, then we will see it. Good opportunity to drink tea, or have you got coffee or tea?
That's tea.
I have had jasmine tea. Have you got not English tea like most people here have? But okay, we have no questions, so let's move on. So MEMETH. Pretend I know nothing about Memif, and you will not be too far from the truth. I do know a bit, but let's pretend I know nothing at all. Can you explain Memif for me? What is it? And before we speak about how it relates to VPP.
Right. So to describe Memif from a higher standpoint, it's a packet interface standard and implementation that's made to be fast and lightweight. So basically it's a way of exchanging packets between two applications that run in user space. As it's user space, you don't have to have privileges to create it, exchange packet to it. So it's really just a user space construct. It's well supported through the industry, so it's a standard that is present in DPDK. You have it in TestPND, in VPP also, obviously, and you have a range of libraries in C and in Go also that allows you to connect, consume packets, write, read, and negotiate the various parameters that you need in it. And it's also, as I said earlier, oriented towards performance. So the idea was to achieve the maximum packets per second that you can on a single. So on a queue on a core, and to also provide options to reduce the number of copies of mem copies in order to get really the maximum throughput that you can.
Nice.
Concretely speaking, it behaves really like a netdev. So you know, when you start a container, you will get netdev normally called if0. That's so in our case, it's backed by Vert.io, and when you want to send packets, you usually call the send and receive on that socket, and that goes into the kernel, and the application then receives the packets on the other side by calling receive. But that forces you to go through the kernel, and that limits performance quite a bit. There are ways to speed that up a bit. You have AF packet and AF XDP that allows you to gain a few cycles there, but the performance gains are not that great, and also you have to run in privilege mode to leverage those. MEMETH is really different in that you have a socket, but you only use it to negotiate. It's just a shared memory, and there is just a protocol where both processes write and read. In that shared memory, there is negotiation so that they don't step on each other's toes. But basically, it's just copy from one place to another.
Nice. So does it have any effect on visibility or anything else from the point of, well, actually, just let's say, instead of or anything else, that's a really unfair question. Let's just specifically ask, does it affect visibility or anything like that at all? Or from the point of view of what, if you wanted to see what the data plane was doing, is it any different once MEMETH is involved, or?
So, the main difference is that as it's not a standard Linux interface, you don't get so all the applications that used to work with regular Linux devs needed modifications to support MEMETH.
Right, gotcha.
So it's a library that you need to integrate with. So you wouldn't have TCP dump, you wouldn't have EF PPS, and you would have to adapt the applications to, at the end, consuming packets.
Yeah, cool. Okay, yeah, that makes sense. Actually, I knew a bit of that from when we did our talk before. All right, cool. What was the reasoning behind not going with it from day one in VPP? Is it just a case of getting the kind of key functionality in place first of all, or?
Yeah, it was the make it work, make it fast strategy. We wanted, so really the first thing we did was we said, can we do kubeproxy within a Calico cluster and make it just one container and a file and make it work? And the easiest for that was to go with regular TuneTap, and once we had that working, we say we want to add MEMETH on top of that. And at that point, you start realizing that in Kubernetes, you have a lot of features that require, to some extent, a regular netdev to be present, because you might have health checks, you might have DNS, you might have all this, which don't speak MEMETH. So that's when that's really a good argument for saying it's there to add MEMETH on top and to do a split. Let's say I want all ports above a certain number to go to the MEMETH, and the rest, NDNS and ICMP goes to the regular interface.
Right.
It's better to do that way than.
Yeah, and as a general kind of software design thing, sometimes you need to. It's hard to move from a blank sheet of paper to that huge set of features. You need to go through those interim stages as well to kind of get working and then fast, as you said. Cool. All right. Well, so I think sometimes things are best explained with a demo. So let's dive into it, shall we? So I'll just cover off. Nathan has really kindly set up a demo for us, as I often do in my own demos. He's gone with using Askinema to do the demo, which I think is a really smart choice. Doesn't matter how reliable your environment is, it will try to explode when you do a live demo. It's just the nature of live demos for some reason. So for that reason, it's an Askinema recording. But if we have time and we have questions, then I think the environment is, I believe, still running. So we'll cover off the stuff that's in the recorded, the keystroke recorded demo, and we can ask questions about that. And then if we have time and more questions, we can try and dig into the environment that's running. If that sounds okay with you, Nathan?
Sure.
Cool. All right, I'm going to try and share your. Let's see if I can do this professionally. I suppose a professional probably wouldn't say they were doing it. So I'm going to switch to your view now. Other share and cams. Let's try this one. I'm going to put us behind the terminal, which so if you just sort of lean a little bit like this, I think that's
I'll beat you up.
Perfect. Yeah, this is good. So actually, I think I might use that kind of screenshot as the thumbnail for the YouTube video. So I think people need to see the terminal more than they need to see our faces right now. So cool. All right. So take it away, and I'll ask questions as we go. You tell us what you think we need to know, and I'll ask anything that jumps out to me that it sounds interesting.
Sure. So let's go. So here so the machine I'm on consists of a single node Kubernetes cluster with Calico VPP installed. So we have the Calico VPP data plane pod, so the part running VPP. We have the regular Calico system, and we have an extra pod called MVPP. That's going to be the one that I'm using for the MEMETH test.
Mm-hmm.
So if we go into VPP, we see that we have the file, it's an AVF, and a bunch of interfaces. And the MEMETH that's going to be of interest to us.
Cool. One thing I want to point out already, because some people won't be familiar with it, is that you just jumped to the VPP CLI, which allows you to see the state of the VPP data plane on the node, right? Which I found really useful. It's in the Project Calico documentation for VPP. I'm sure there are a million commands there that are probably not supported and not in our documentation, but even if you just want to get some visibility of what your interfaces are and the state of them, the MTU and the counters and things, that's really useful.
It contains roughly the IP route equivalent within VPP, so you can play with routes to see the status of everything.
Mm-hmm. Cool.
So if we switch to the YAML file that I added to create the pod I'm going to play with. So basically, it's just a regular Ubuntu container. So I added privileges and huge pages and stuff to make it really easy, my life easier. Mm-hmm. But you could run with a regular unprivileged container. Mm-hmm. And I asked with the two annotations there that I wanted MEMEF for TCP above 4444 and UDP above 444. So all the traffic above those ports will be redirected to the MEMEF within the pod.
Cool. I noticed you had the other port set to you had it set for TUNTAP to default. Does that just mean that default accept what's overridden by the other line?
Yeah.
Yeah. Cool. Brilliant.
So you can do it both ways. So here in the schema we said either the default traffic goes to the ETH0 interface or to the MEMEF, mm-hmm. and you can extract a bit of the traffic to go on the other one. The objective being that you can still receive part of the traffic where that's interesting for you, and you can still do DNS and such from within the pod.
Yeah, makes sense. Cool. All right, so you've popped up a cool diagram for us.
Yep. So that's the diagram. So we have so here that's the node we're in with the Kubernetes and the Calico installed and VPP here. Mm-hmm. And in order to test the performance we can get, I have attached another node, so it's another machine mm-hmm. That will only do traffic generation in order to reduce the number of bottlenecks. So I really reduced the situation to the bare minimum in order to have as few bottlenecks as possible, mm-hmm. in order not to be limited by some switch in the way or just the fact that you have to go through another MEMEF on the packet generation side.
Yeah, makes total sense. Yeah.
The link is 40G. It's an XL 710. Mm-hmm. So we should be able to see traffic up to 40 gigabits.
Perfect.
There, and the pod is here with the ETH0 and the MEMEF.
Have you seen VPP running on 100 gig yet? On 100 gig hardware?
We are starting to play with those. I was discussing just yesterday with the guy who wrote the host stack, mm-hmm. and he's always trying to push its TCP stack as faster and faster. I think was able to do 50 gigs on a single flow, something like that. But I won't speak for him because but it's really nice.
These numbers are insane to me. I haven't actually. I think I know 40 gig is the biggest hardware I've ever touched. But yeah, anything beyond that is just mind blowing to me. Cool. Okay, let's see what's next.
So let's go into the pod. So I open a bash console within the MVP pod, the one with the MEMETH.
Mm-hmm.
So you can see that we still have the if0 interface configured.
Mm-hmm.
But if I do an netstat-l, I see that we have an abstract socket called add_vpp/memeth that lives there. And so that's the socket we're going to use to attach, to create the memeth and to get packets.
Okay.
The one that you have to pass in the configuration. So first, let's see the performance we can get with F0. So we open an EFPPS, and let's move to T-Rex. So that's the traffic generator.
Mm-hmm. Yeah.
And we are gonna generate 64-byte packets at the highest rate possible with this, and see how much we can receive on the other side. So we see that we generate 40 million packets per second, so it should be enough to saturate the other side.
Mm-hmm.
And here we see that we received about 1 million packets per second on the regular NetDev interface.
I'm not as. I see. Yeah. Sorry, I was.
So that's the.
Yeah, I see it now.
So it's about 1 million. So that's roughly the order of magnitude what Linux can do.
Mm-hmm.
To have another data point, we can test with 500 bytes, 1,500 bytes packets.
Mm-hmm.
So obviously the generation rate will drop, but it's still a couple million, so it should be enough.
Mm-hmm.
And here we are receiving so roughly a bit less than 1 million, so 800K BPS. But the interesting number is the throughput. So here we have megabytes, so it's roughly a bit lower than 10 gigabits per second.
Mm-hmm. Yeah.
Of traffic with regular 1,500 byte packets. So that's about the performance you can get with regular NetDev.
Yeah.
So now I'll stop the traffic generation and get back to my pod, and there I will start a new VPP. So it's a distinct VPP instance that I will use to connect with the MEMEF. So here you could use your own application, connect it with the CMEMEF library or GoMEMEF, or
I see. So
or use even TestPMD.
So this is essentially a demo client application.
Yep.
Okay. Cool.
So the reason why I use VPP is because as it's easy to write plugins and to I was able to write a small EFPPS replica within VPP.
Okay.
So
interesting.
So here we can see the MEMEF and start polling the packets. So let's regenerate packets with 64 bytes. And here we can see that VPP is able to receive around 11 million packets, mm-hmm. compared to the million that we had in Linux.
So wow,
that's a significant speed up.
Yeah, really.
We can do the same thing with the 1,500 byte packets, and here we see that we are saturating the link.
Mm-hmm.
So we have the 40 Gs. So we should be able to maybe go higher if we had 100 gig links, but sadly I'm limited there.
Yeah. Oh, that's fantastic.
But should be well enough.
Yeah, that's really good to see. It's really consistent as well, isn't it? Nice.
Yeah. It holds.
So actually, that leads to another interesting question. If you want to pause it just for a sec. So you mentioned about building a client application. So if someone wanted to do that, where is the best place for them to go to see how to implement what they need to implement in their client application if they want to make it play well with VPP? With MEMETH, I should say.
So we have we have some Go boilerplate that's really easy to do. I think so on the VPP documentation, I should check, but we have revamped the documentation since a couple of weeks, and there should be boilerplate code to try this out. Nice. To check if everything's there. But the one good example also would be the TSPMD. So either TSPMD or just or a plugin within VPP that would also work.
Awesome. Yeah. So if anyone is looking for that and they are struggling to find it at all, then like I said before, if you join us on the VPP channel and the Calico user Slack, either Nathan or myself or someone else will help you to find it. Cool. Okay. Thanks, Nathan. Okay, yeah. Sorry. Carry on. I interrupted you.
So no problem. So the final example I want to do is so this also for now I only spoke directly to the pod IP on the port that I specified for the MEMETH, but the talking to the service IP. So I define only a single service IP for the pod, but that should also work. So here we are a bit lower. We are like 46 gigabits per second received within VPP, which means that I still have work to do optimizing this because I know where this performance discrepancy is. But anyway, we are quite close to the full speed link, full link speed also. So that will work, and that's actually one of the interesting parts because with MEMEF we are exposing something to application doing packet processing. So it's really worth going to MEMEF and paying the price of changing your application to consume that if you are really interested in handling tens of millions of packets per second on a single core, and really multiple tens if you're doing multi-queue. But you could also benefit from the regular Kubernetes construct for that. So that means you could use also the service IPs, the policies, all that, provided that they don't degrade performance too much. And I think that's an interesting features that because so you could think of it as a complementary solution to SRIOV. So if that level of performance is enough, that allows you to have a bit of the world of Kubernetes and a bit of the world of the fast PPS world, basically SRIOV. A bit of a middle ground between those two.
Yeah, I think that is something that actually people do want because the convenience of Kubernetes is amazing, but yeah, sometimes you just need raw performance, and that's definitely a thing. What impact does this have, or how does this play with the encryption features?
So it behaves seamlessly with. So if you define, let's say, a WireGuard tunnel between your nodes, obviously performance is going to be reduced to the levels that crypto is able to give you. But so if I recall the numbers correctly, we were able to TX around 10 Gs to 10 gigabits of traffic through a WireGuard tunnel, and a bit more for IPsec. IPsec is around 15 to 18, depending on the test and if we have the wind behind the back. So raw throughput should follow these rules. If you are exchanging small packets, obviously the rate is going to drop, but you should still gain multiple factors of performance compared to implementations going through the kernel.
That's incredible because, I mean, obviously some users can't use WireGuard. They need to use IPsec because they have compliance or FIPS or whatever. And to get that kind of performance from IPsec is incredible. Awesome. All right, let's carry on.
That was mostly it for the demo that I had. So I really try to keep the test samples to show only a single flow. So we also did some other tests where the traffic was coming back, but as soon as you start to make the path of the packets longer, you start to hitting bottlenecks at multiple places. You never know what it starts to get fuzzier, so I choose to stick with that one.
Yeah, it's amazing how just adding a few things makes it the problem space becomes exponentially way harder to I know from too many times in my career. What about latency? We mainly focused on bandwidth, but obviously the latency is going to be very low anyway. But is it measurably faster or?
So we did some tests a while ago, and it was a bit faster, but as latency is quite small in cases where the system is not that loaded, we didn't see that much of a difference. So we did test with really huge number of services, of rules, and that impacts a bit other implementations. But yeah, that was the. I think I would say I don't recall the result that much, and I recall that we were a bit ahead, but the difference was not in the order of really halving the time.
Yeah, that makes sense. I mean,
it was just a few percent.
Yeah. Well, that's fine. And the fact that you don't particularly remember the outcome is a good sign, because if you would remember it if it was bad, that's for sure. Yeah. So.
And also it seems for now in the use cases that we encountered, latency was not that of an issue in the case that so it was not the primary concern that people had. So, and I assume because it's already good enough, I think, on most of the system. I think the most of the latency comes from hopping from one machine to another rather than going through the stack.
Yeah, makes sense.
When it's not loaded.
So, if people wanted to get, actually, I should ask before we move on to other things, or to talk about other parts of this. If anyone has any questions, I noticed we did have a comment a moment ago about the Calico cat. This is the story of my career, Nathan. I get outshone by a picture of a cat. So, but if anyone has any questions about anything that Nathan and I have been talking about, feel free to hit us now. And obviously, this is quite deep technical stuff. So if you feel unsure of your question, it's totally fine to ask simple questions now. And if you'd rather come and talk to us on Slack later on, that's totally fine as well and understandable. So yeah, if there aren't questions, while we wait to see if we do get any other questions, what is the readiness of VPP and MEMETH in terms of people getting involved? So if someone wanted to come along and spin something up now, are they in a position to do that, or is it too early for that? Or
yeah, that's so. I wouldn't say that it's production ready, battle tested yet. It definitely works. So MEMETH, as it's sold, is used in production, and it's really battle tested in kind of a lot of ways, and that's also the reason why it's supported a bit everywhere. But so on the integration between Calico VPP and MEMETH, this should work out of the box. So you just have a flag to pass to. So we added a global kill switch to be sure that you don't enable it by accident and as a security feature. But apart from that, you just enable the global switch. It's a single variable, and then you add the annotations you want, and you can play with it. In the repo, there are a few examples, one with SPMD, and I haven't yet upstreamed the example I used for this talk, but I'll definitely do that.
Nice. Yeah, I might. So later in the week, if I can just find the time, I might actually try this myself. I would be quite interested in doing so. Cool. That's really useful. I'm just thinking if there's anything else we should cover off while we have the cluster up. I can't really think of anything else at this point. Was there anything else that jumped out at you that you wanted to share?
On that cluster,
don't think so.
I think in terms of test, I'd be ready. I have a few other features, mostly things coming up into the that we want to add also.
Yeah. Well, we can talk about that. If you're happy to talk about that, then let's do that. We have about 5 minutes before we need to wrap anyway, so it's fine. Okay. It's fine to finish early if we need to, but if you have other things to talk about, that'd be very interesting.
So the last thing I want to we think because we are always trying to add new features and to explore the thing, because now that we have that great platform to implement new things, we are starting to really try and leverage it and bring value out of it. So the thing that we've been working on recently is the multiple interfaces. So in addition to MEMETH, what we want to enable and to do is, in a fashion similar to what Multus and Dynam are doing, provide a way to add multiple interfaces within a pod. So for example, you would have a series of MEMETHs and expose functions behind those MEMETHs. So for example, you say, I want an interface that's connected to a specific network, maybe a VLAN, maybe some kind of uncap that VPP supports. And we are exploring also this as a way to create more complex network functions leveraging this, or just with regular interfaces. But we are also, so there is right now an exploration in that sense.
That's really interesting. So do people tend to want to do that for performance, or to bind particular traffic to particular NICs? It's not something, to be honest with you, it's not something I've dug that deeply into.
So it's the generic use case is, for example, if you want to build a proxy, you would have or let's say your NAT gateway. You want to host your home gateway within Kubernetes. On one side, you would have your home network, maybe a network with your with a guest network, and a third leg connected to the internet. And those specifications so for now, Kubernetes only has one leg, and you can differentiate by doing uncaps, and it would be nice to have a generic framework of specifying, I want the infrastructure to provide me an access to those things in a pod, and not care really about the internal logics of everything, where traffic is flowing. And
yeah, the other multi-NIC kind of setups I used to do back when in my, when I was doing kind of data center engineering was often for SAN and storage applications as well. So I don't know if there's an application for that as well.
Yeah, there might be, definitely.
Yeah, cool.
So, but if there are, and it's still exploratory. So also, if anyone has a specific use case and want to talk about this, would be happy to chat on the Slack also.
Yeah, it's a great time to get involved and kind of help to direct the conversation and get the features that you want noticed. One thing I should have asked you before when we were doing the demo, when you were doing the demo, is what if any additional requirements are on the node if you want to implement MEMETH? Is there anything in terms of hardware or kernel version or anything else that the node needs to have?
No, it's really as everything is user space, VPP is user space. The only requirement that you have is that you, if you have ARM, that is compiled for ARM. If you have x86, that is compiled for x86. Apart from that, it is the only requirement. You will get different optimizations if you have an instruction set that support vectorized instruction, for example. But apart from that, MEMETH is really one process speaking to another. So as long as the two are able to compile, things should work fine.
That's it. Cool. Okay, that's really, really interesting. Thank you. I learned a ton of things, so I'm sure other people did as well. All right, well, we're nearly out of time, so I just wanted to quickly just let people know what we're doing for the next session. We're going to have Peter Kelly joining us. Peter Kelly is the site lead of Tigera in Cork. We haven't really, to be honest with you, we haven't set the full agenda yet. It's likely we'll talk around the strengths and nuances of WireGuard and Calico, because that's something that Peter knows a great deal about. So I'm excited. I think that's I think it's actually in 3 weeks' time due to calendar conflicts. So we'll be nearly at Christmas. So you can consider that a Christmas present, if that's the kind of thing you like for Christmas. So cool. Well, with that, I think it's time to wrap. So there will be a recording of this session if you want to go back over and share with your colleagues anything that Nathan showed us. And like I said, I know I'm laboring the point, but come and join us in Calico User Slack on the VPP channel. And that's it. And if not, then Nathan, thank you so much for taking the time to do this. I know it's... And
thank you so much also for inviting me. That's
no worries.
Much appreciated. And
yeah,
Just wanted to say that the collaboration with the Calico team has really been great, and we are really thrilled to be a part of.
Oh, thank you.
So
Yeah,
contributing to this.
Yeah, and as you know, I'm relatively, I joined Tigera back in March, so I'm relatively new to the conversation in terms of this group of people. But yeah, it's a really helpful, supportive group of people. It's really nice. So yeah, come and get involved with us. All right, thanks, Nathan. I think that's a great place to leave it. So enjoy the rest of your day.
Thanks, you too.